Today we will learn about factors of the form x plus a into bracket x plus b. Suppose we are required to factorize this algebraic expression. Can we use these identities? Think. Let me tell you, here the number 20 is not a perfect square. So this expression is not of type a plus b bracket square or a minus b bracket square. That is, it is not a square expression. Similarly, we also see that it is also not an expression of type a square minus b square. Here, we will use this identity. If the expression corresponds to the right side of this identity, then its factors correspond to the left side of the identity. This is the fourth identity of algebraic expressions that we have studied earlier. Let's try to arrange this expression. According to this identity, if we compare this expression with the right side of the identity, then we see that the coefficient of x square is 1, just like the right side of the identity. In the same way, the coefficients of the second term in both expressions gives a plus b is equal to 9, and coefficients of the third term, that is constant term in both expressions, gives ab is equal to 20. Now we will find the values of a and b so that both these conditions are satisfied. That is, we need two numbers whose product is 20 and sum is 9. Will you be able to find two such numbers? Think. Let me tell you, two such numbers are 4 and 5 because 4 multiplied by 5 is equal to 20 and 4 plus 5 is equal to 9. In this way, we can write the middle term 9x of the expression x square plus 9x plus 20 as 4 plus 5x. In this way, we have arranged the given expression as the right side of this identity. We can write it like this by removing the brackets. X square plus into bracket 4 plus 5 x plus 20. X square plus 4x plus 5x plus 20. The first two terms have x as their common factor. So we can take x outside the brackets and represent this group as x into bracket x plus 4. Similarly, 5 is the common factor between the third and fourth terms. So we can also take it outside the bracket and write this group as 5 into bracket x plus 4. Now we see that x plus 4 is a common factor, so we can take it common and write the expression as x plus 4 into bracket x plus 5. In this way, the factorization of x square plus 9x plus 20 is x plus 4 into bracket x plus 5. Generally, to factorize the expression of type x square plus bx plus q, we find two factors a and b of constant term q such that ab is equal to q and a plus b is equal to p, using which the expression can be arranged as x square plus a plus bx plus ab. It can be written as x square plus ax plus bx plus ab. With further factorization like this, we will get x into bracket x plus a plus b into bracket x plus a, which is equal to x plus a into bracket x plus b. These are the factors of x square plus bx plus q. In this process, we have splitted the middle term. Thus, we also understand this process by the name middle term splitting. So, can you tell me how we can factorize x square minus x minus 42? Pause the video and try it. Let me tell you, here the coefficient of x square is 1, the coefficient of x is minus 1, and the constant is minus 42. We have to find two numbers a and b for which product is minus 42 and the sum is minus 1. The conditions in which we get the product of two numbers minus 42 are as follows. Now, can you find the two factors of 42 which when added gives result minus 1? Think. Correct. The sum of 6 and minus 7 is minus 1, and so we will choose 6 and minus 7. Now we can write 6 minus 7 at the place of the coefficient of x, that is minus 1, in x square minus x minus 42. Thus we get the expression x square plus 6x minus 7x minus 42, that is x into bracket x plus 6 minus 7 into bracket x plus 6, that is x plus 6 into bracket x minus 7. Solving in this way, we will get the factorization of the expression x square minus x minus 42 as x plus 6 into bracket x minus 7. Now, you must have understood this method very well. So today we have learned the factors of the form x plus a into bracket x plus b. In the next video, we will see some interesting examples related to them. Today we will see some examples related to factors of the form x plus a into bracket x plus b. Area of rectangle has algebraic expression. Find the expression for the length and the breadth of this rectangle. We know that the area of a rectangle is length multiplied by breadth. Here, the area of rectangle is given in the form of algebraic expression x square minus 12x plus 32. If we factorize it, we will get an expression for length and breadth of rectangle. So, let's get started. Here, we will use this identity. We will divide the middle term, that is, the coefficient of x, into two numbers a and b in such a way that ab is equal to 32 and a plus b is equal to minus 12. Since minus 8 multiplied by minus 4 is equal to 32 and minus 8 plus minus 4 is equal to minus 12, we will choose minus 8 and minus 4. Now, the middle term minus 12x of this expression can be written as, which can also be written like this. Now, we will take x common from these two terms and minus 4 common from these two terms. Now, we will take x minus 8 in common from both these terms so that we get the factorization of given expression as x minus 8 into bracket x minus 4. We know that the area of a rectangle is equal to length multiplied by breadth. Therefore, we can say that the length of rectangle is x minus 8 and breadth is x minus 4, or the length of rectangle is x minus 4 and breadth is x minus 8. Now, let us understand an interesting thing related to factorization of algebraic expression with an example. A teacher asked students to factorize the given expression. Tina and Sachin solved it with two different methods. Tina simplified it by splitting the middle term, that is, she used this identity. She had find two numbers a and b to split the middle term minus 12x in such a way that AB is equal to 36 and A plus B is equal to minus 12. Since minus 6 multiplied by minus 6 is equal to 36 and minus 6 plus minus 6 is equal to minus 12, so she chose minus 6 and minus 6. She expressed the middle term minus 12x of this expression as, she simplified it in this way. She took x from these two terms, minus 6 from these two terms as a common factor. Then, from these two terms, she took x minus 6 as the common factor. Thus, she obtained the factorization of the given expression as x minus 6 into bracket x minus 6, which we can also express as x minus 6 bracket square. Instead of solving like Tina, Sachin used identity to factorize the given expression. In this expression, the first term x square and the third term 36 are both perfect squares. Sachin wrote the second term minus 12x as minus 2 multiplied by x multiplied by 6 and wrote the given expression like this. The expression corresponds to right side of this identity where a is equal to x, b is equal to 6 and minus 2ab is equal to minus 2 multiplied by x multiplied by 6, that is minus 12x. Therefore, we can write the factorization of this expression as x minus 6 bracket square similar to the left side of the identity. Thus, both have obtained correct answer. In this way, we have seen that the factorization of given expression can be done by using standard identity as well as by dividing the middle term, that is, using this standard identity. Generally, the expressions that corresponds to right side of these identities can also be factorized by the middle term splitting. So today we have seen some examples related to factors of the form x plus a into bracket x plus b. In the next video, we will see some simple mistakes related to them. Today we will see some common mistakes related to factors of the form x plus a into bracket x plus b. Mistake 1. Children are not able to split the middle term correctly while factorizing an algebraic expression of type x square plus into bracket a plus b x plus ab. For example, if they are asked to factorize the expression x square plus 8x plus 12, then they split the middle term 8x as 4 plus 4x. They do not understand that the numbers taken should be factors of constant term 12. After dividing the middle term, they simplify it in this way. Some children are unable to simplify this further and think that the factors of given expression cannot be found. Some children think that x plus 4 can be taken as common here, so they write this expression as x plus 4 into bracket x plus 3. These are wrong answers. We can only take a factor common if it is a factor of at least two terms. Keep in mind that to do the correct factors, we have to choose those factors of 12 whose sum is 8. Such factors are 6 and 2. So we can write x square plus 8x plus 12 as x square plus into bracket 6 plus 2 x plus 12, which on further solving we get. Here you can see that x plus 6 is the factor of both these numbers, so x plus 6 is a common factor. Hence, we can take x plus 6 common. In this way, we will get x plus 6 and x plus 2 as the correct factors of this expression. Mistake 2. The number written before the variable is called its coefficient, just as in 2x has coefficient of x is 2. In 9x square, coefficient of x square is 9. If the coefficient of a term in the expression is 1, we generally do not represent it. For example, the coefficient of both x square and x is x square plus x minus 2 is 1. Some children do not have this idea, so they are not able to factorize algebraic expressions like x square plus x minus 2. Remember, if no coefficient is given in any term, then in that case we should take coefficient 1. So here we will take coefficient of middle term x as plus 1. In this way we can write minus 2 is equal to 2 multiplied by minus 1, from which we will get 2 plus minus 1 is equal to 1. Now we can write x square plus 2x minus x minus 2, so that we get the factors of this expression as x plus 2 into bracket x minus 1. Mistake 3. Some children do not understand that the coefficient of x square is 1 in the identity x square plus into bracket a plus b x plus ab. So we can use this identity only if the coefficient of x square is 1. If children are asked to factorize algebraic expressions 3x square plus 3x minus 18, then they do not pay attention on the coefficient of x square, that is 3. They keep it simple, but at times they reach a situation when they cannot simplify further, so they think that given expression cannot be factorized. Note that if the coefficient of x square is any other number than 1, rearrange the expression and bring it in the form of x square plus into bracket a plus b x plus ab. For example, here if we take 3 common to all terms, then we get 3 into bracket x square plus x minus 6. Now we can factorize x square plus x minus 6. For this, we will find two numbers whose product is minus 6 and sum is 1. Those numbers are minus 2 and 3. That is, the factorization of given expression is 3 into bracket x minus 2 into bracket x plus 3. So today we have seen common mistakes related to factors of the form x plus a into bracket x plus b, x plus b, x plus b, x plus b.